Hi, welcome to xmTuition, where I help everyone with their physics homework. Like yesterday, the neighborhood cat asked me to explain this question. So this question is about the displacement distance graph of a wave. So we know that there's a wave that's progressing rightward, and all we are seeing is the wave profile of the wave at one instant in time. So let me repeat, yeah? There's a wave that's progressing rightward, and all we are seeing is the wave profile at one particular instant in time. But what is each point on the wave doing? Since this is a transverse wave, every point is oscillating vertically up and down, and together they form this wave profile. So how can we tell which point is at this instant in time moving downward? Well, it cannot be point B, because point B is at the extreme position. It's oscillating up and down, but at this point in time it's at the lowest point, and we know that for an oscillation the velocity is zero at the extreme position. So point B is instantaneously at rest. The same goes for point D. So between point A and point C, which point is moving downward? Now, one good approach is to animate the wave profile ourselves. Since the wave is moving rightward, right, and currently it has this wave profile, then a split second later the wave profile should have moved a bit rightward. So it will have progressed from the black profile to the blue profile. But we know that point A is actually oscillating vertically up and down, right? So if the wave profile is to go from the black line to the blue line, it means that point A is actually moving from here to here. So point A is actually on the way up. What about point C? If the wave profile goes from the black line to the blue line, then point C has to move from here to here. So point C is on the way down. I know many students are going to ask, then isn't point D also on the way down? See, at point D, the wave profile goes from the black line to the blue line. So isn't point D like on the way down as well? This is when using this method could be misleading, yeah? To get the full picture, actually you have to consider the wave profile just before this point instant in time. So a split second earlier, the wave profile will look something like the red one before it becomes the black one, before it becomes the blue one. So what does this tell us about the motion of point D? It was actually somewhere below on the red line, then rises up to the black line, and then goes back down to the blue line. Then you get the full picture. Point D is actually not on the way down, it was on its way up, and then it's going to go on the way down. But at this very instant, point D is actually at rest. The same thing goes for point B. So my advice will be to use this animate the wave profile method only to find out the direction of motion at points that are not on the extreme positions. For points that are at the extreme position, just know that the instantaneous velocity is zero, since they are at the extreme points of the oscillations. I hope everyone will continue to ask me questions, then we can all learn together. Ta-ta!